equations. There are 3 ways of solving quadratic equations. You can solve it by factoring, which you should know how to do by now. You can solve by completing the square, or you can solve by using the quadratic formula. We're going to focus on the first and the third of these, because if you know how to do those, you really don't need to know how to complete the square. I'll show you one example of completing the square, but we'll focus on factoring and using the quadratic formula. So, solve x squared minus 6x minus 16 equals 0. We should be able to factor this. I'm pretty sure this factors. Right? So, an x and an x. We're looking for 2 numbers that multiply to negative 16 and add to negative 6. It's going to be a negative 8 and a positive 2. Now, if we've got 2 things multiplied together that both equal 0, that multiply together to be 0, one of them has to be 0. So either x minus 8 equals 0 and x equals 8, or x plus 2 equals 0 and x equals negative 2. We get 2 solutions, which it's a degree 2 polynomial, so there should be 2 solutions. We got 2. Awesome. We can also do this by what's called completing the square. So to complete the square, you want to move your constant over to the other side. So we're going to add 16 to both sides and make this equal to 16. Now, think about when we have x plus some a and we square it, right? This would be x plus a squared. We would FOIL this, and we would get x squared plus xa plus xa, which would be 2xa, or let's call it 2ax. And then we would get plus a squared. So when you square a binomial like this, you're always going to get something in the middle that's 2 times whatever this number is. So what could we square in order to get negative 6 in the middle? Divide that by 2, and that's going to be negative 3. So if I FOIL x minus 3 times x minus 3, all right, that gets me x squared minus 3x minus 3x plus 9, which is x squared minus 6x plus 9. So there's our x squared minus 6x. But wait, we've got this extra plus 9. When we went from this step to this step, we added 9 here. So, in order to keep things balanced, just add 9 to the other side as well. This is going to be x minus 3 squared equals 25. Square root both sides. Now remember that this could be 5 or it could be negative 5. Let's actually, right? Could be positive or negative 5. So do them separately. X minus 3 equals positive 5 or x minus 3 equals negative 5. Add 3 and add 3, and that's either x equals 8 or x equals negative 2, which is the same pair of answers that we got over here. The last way that we could do this is the quadratic formula, which will show up on another slide in a minute, but x equals negative b plus or minus the square root of c squared minus 4ac, b squared minus 4ac, all over 2a. So my Algebra 2 teacher made us sing it to the tune of Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. Which I'm definitely going to make y'all sing in class at some point. If for no other reason than to amuse me. Anyways, so A is your leading coefficient, which is 1. B is -6. C is -16. If you plug all of these in here, 6 plus or minus square root of 36 minus 4 times 1 times -16 all over 2 plus or minus the square root of 100 over 2, which is 6 plus or minus 10 over 2. And 6 plus 10 over 2 is 8, and 6 minus 10 over 2 is -2. And hey, it's the same two answers that we got the other two times that we did it. So when you're solving a quadratic, you can solve by factoring, if it'll factor. Sometimes if the solutions are not integers or not rational numbers, it won't factor, or you can't factor it easily, in which case you would need to do one of the other two methods. I recommend the quadratic formula. It's a little bit more work, but it's pretty straightforward. And it never fails as long as you do it right. So this, I can tell right away, is not going to factor. I'm reasonably sure this is not going to factor. So what I would need to do is I would need to either complete the square or I would need to use the quadratic formula. Because of this 3 out front, completing the square is going to be a pain as well. So I'm going to go straight to the quadratic formula. So -b plus or minus square root b squared minus 4ac all over 2a. -7 plus or minus the square root of 49 minus 81 over 6. No, not 81, 84. There we go. Which is going to be -7 plus or minus the square root of 35, -35. Yeah. All over 6. 35 is not a perfect square, doesn't have any perfect squares that go into it, so you can't reduce that. There's nothing, no factors that cancel out in the numerator and the denominator. I would just leave this like this. This is the answer. It does not simplify in any meaningful way. So I would say just leave it like this. Right? So, quadratic formula. For an equation in the form ax squared plus bx plus c equals 0, you get the formula -b plus or minus the square root of b squared minus 4ac all over 2a. The part under the square root, the b squared minus 4ac part, is called the discriminant of the equation. The discriminant tells you the nature of the roots of a quadratic or the zeros of the quadratic function. So, if the discriminant is positive, right, you got a positive number under here, you're going to get 2 real roots. Because you're going to get the square root of some number, and it's going to be either plus that or minus that. If the discriminant is 0, then this whole thing would go away, and you just have the -b over 2a. And so that would be only 1 real root. It's actually a double root. So when we say that a polynomial function, has as many roots as the degree, that includes double roots, right? If I have x minus 1 squared, right, that's x squared minus 2x plus 1, that's a degree 2 polynomial, but it's only got 1 real root. It's going to have a root at 1 because that root is doubled. So that's the case. If your discriminant is 0, you have one real double root. And then if your discriminant is negative, right, if you have a negative number under the square root, you don't have any real roots. You get 2 imaginary roots instead. Mark McGwire of the St. Louis Cardinals broke the home run record with his 62nd home run of the year. He went on to hit 70 home runs for the season. Besides hitting home runs, McGwire also occasionally popped out. Suppose the ball was 3.5 feet above the ground when he hit it straight up with an initial velocity of 80 feet per second. The function d of t equals 80t minus 16t squared plus 3.5 gives the ball's height above the ground in feet as a function of time in seconds. How long did the catcher have to get into position to catch the ball after it was hit? So if I write this in order, from greatest to least exponent, right, so it would be negative 16t squared plus 80t plus 3.5. And this is not going to factor, and it's going to be really tricky to solve by completing the square. So we're going to jump right into using the quadratic formula. So negative 80. So what we're looking for here, right, if we sketch this, this is a parabola, and it opens downward because it has a negative in front. And so we want to know the time it's going to take before the ball hits the ground. So we're setting this equal to 0 and solving for t. So we're going to use the quadratic formula. And so this is going to be negative 80 plus or minus the square root of 80 squared minus 4 times negative 16 times 3.5 all over 2 times negative 16. Which is going to be negative 80 plus or minus the square root of 6,400 plus 16 times 3.5, sorry, 224, all over negative 32. 6624. And so that square root is about 81.4. So negative 80 plus or minus 81.4 over negative 32. Now, if you do plus 81.4, right, so negative 80 plus 81.4 over negative 32 is going to be 1.4 over negative 32, which is a negative answer. So you get a negative time there, and that doesn't make any sense. So we want to do the subtraction, negative 80 minus 81.4 over negative 32. Which is going to be negative 161.4 over negative 32. And our negatives cancel out. And that is going to give us about 5.04 seconds. Find the discriminant of x squared minus 4x plus 15 equals 0 and describe the nature of the roots of the equation. Then solve the equation by using the quadratic formula. So the discriminant, remember, is the b squared minus 4ac part of the quadratic formula, which is going to be negative 4 squared minus 4 times 1 times 15. 16 minus 60 is negative 44. So if your discriminant is negative, that means that there are no real roots. There are 2 imaginary roots instead. So when we do our quadratic formula, negative b, so negative 4 is a positive 4, plus or minus the square root. We already did the b squared minus 4ac part, so I can go ahead and stick that in there, all over 2a. A is just 1. So 4 plus or minus, we can turn this square root of negative 44, so it's still a negative, right? So, but we can pull out, if we factor out a negative 4, right, factor this to be negative 4 times 11, and make these separate square roots. The square root of negative 4 is 2i, and then we have the square root of 11 over 2. And the reason I did that is because that becomes a 2, and those 2's cancel out. You can divide everything by 2. So 2 plus or minus I square root of 11. And that's good enough for me. And that's it for the quadratic formula. Again, this should be review. It should be stuff that you learned in Algebra 2. And next time we're going to talk about the remainder and factor theorems. Fun stuff.